Hello everyone, this is Mr. Ege, and we're going to be focusing on how to use Inventor in creation of sheet metal tin container project. And this is a mechanical engineering project, but it's an example of also how to use principles of engineering design in general, because engineering is a data-driven methodologies, the system. Projects and designs are made based on numbers, calculations, computations. That data has to be numerical or logical or methodology coming from, or could be a mixture of everything, including the rules, laws, ethics, and everything. All of this has to be based on a reference, okay? So that's why you need to calculate the length and width and height of the container and the volume of the container based on maximum volume. Demand coming from our client, a container made out of only 8 inches by 8 inches sheet metal. And that's, I decided to make it from aluminum after having a conversation with the client myself. And this is going to be maximum volume can be made from 8 inch by 8 inch aluminum sheet metal, which is going to be also 16 gauge. 16 gauge is about 0.064 inches. So we're going to start from scratch, start the Inventor. By the way, it's a simple box, open top, open rim box. But in the simple box, you're going to find most of the engineering design principles, engineering, manufacturing, engineering principles. And that is data-driven engineering. Engineers, they most of the time do not get all the numbers and data they have to do research. They have to provide the computations, calculations to get those numbers. You are not going to be given correct sizes and dimensions or volumes information, but you have to calculate, compute them yourselves, and find out from the whatever the resources you think is right, and also present to your clients and authorities, together with the drawings. So drawings always start with data. Data has to be extracted throughout your research. So in the instructions, I gave you a number of formulas to calculate the dimensions, and step by step. If you have any difficulty finding out what the exact numbers, correct numbers are, call me. I'll work with you on that, okay? And but this final product, after you know the volume, after you know the dimensions, now finally we need to design it, okay, in the Inventor. Sheet metal application on Inventor is a totally different aspect of the Inventor. We have been using Inventor. You have been mastering the Inventor in multiple different aspects of it, but you never did the sheet metal. So this is going to be the first one. And come to think of it, sheet metal is quite a few applications around us. There are so many of them that we cannot stop. I mean, we cannot come to the end of it. I mean, all the rockets, all the cars, all of the boats, planes, you name it. I mean, sheet metal is in furniture. Everything is in life, in our life. Conveyors, you name it. I mean, the doors and windows and everything. So that's a totally different application practice. And I worked with the manufacturers earlier in the manufacturing labs and places. So I know there are certain techniques that we should be applying. One of them is finding those dimensions, calculating them correctly. And even when you're given dimensions, you have to make sure. Okay, so start Inventor, please, and click on New button. And this is the screen you're going to see in front of you. Because it's the dimensions we're currently operating for this project is English, not the metric. If you choose metric, it's going to millimeter options, but we're going to English option for inches. Okay, and select the sheet metal inch version of .ipt. This is a part drawing. Okay. Multiple part drawings, as you know, come together, makes an assembly drawing. But in this particular case, we don't need assembly drawing. We need a part drawing. Click on that. If you go to projects, there are two options here. You get to name your own project, or you get to choose a default project. Okay. Either way is fine, but default, I'll go with the default now. There's nothing special right now. So we're not creating a new project. So we're creating a default project template. Okay. And click done. And click on the create button now. Okay. So this is your empty space. And what do you do first? You choose a plane. What kind of plane will that be? So let's go to um, XZ plane. How about XZ? XZ is good. Okay, you choose the XZ plane. All right. And click on the create sketch. And now we have the reference point, starting point. And we created sketch number one. We are starting with the rectangle. This is one of the side walls. Okay, so move your cursor over after the clicking on the rectangle, obviously, over the reference point, 0, comma 0 point. Okay, and create start. After you pick the first point of the rectangle, computer will give you option of typing the length. Okay, and I'm going to type. And then press the tab key, and I'm going to type the height. Okay, enter key. All right, so this is the rectangle that I like to have. All right, and so as soon as you create the first thing, you want to move your cursor over, check button, and accept. And dimensions are also created. This is the interesting thing about it. So dimensions are useful. And the way they're showing you actually it enables you to use some iLogic features. I'm going to demonstrate how to use those dimensions later on into the iLogic. This is going to be another lesson, not now. So click on OK button, check button to accept it. Okay. And this is certainly not the bottom view, so I'm going to change. I want to change this view to side view or front view, something like that. Set current view as front view. Okay. All right. Now that this is done, I'm moving my cursor on the top left-hand corner. There's a face option. So we're creating a face. Okay. That's similar to extrusion that we did before earlier. All right. So if you go click on the face, it gives you a bunch of options. Okay. And that is a profile already selected, right? You want to go two-way operation, two-way extrusion. It's similar to extrusion. That's why I'm not going to explain too much. Follow defaults is fine. I don't have problem. Okay, apply and okay. Okay. Now that this is created, though, we have to now visit one more place. Okay, after the face option, you're gonna go to defaults and check it out. What the defaults are. Okay. Defaults are important because it will give you access to how the manner that corners are going to be created. Not the edges, but the corners. Corners are critical because you do not want the wrinkles on the corners. When you bend a metal, okay, because of the thickness of the metal, all right, corners originally create a wrinkle because there is no solution, but geometric, mathematical solution. When you bend two sides at one point, managing that corner, one particular point of the intersection of the two planes, doing perfect, okay? Because you're bending, you're extending the metal, okay? Expanding and extruding the metal. So that's why you want to go and specify a few things. One of them is a sheet metal rule. First of all, thickness rule. I'm going to change the thickness rule. And this is going to be 0 0.064. Yeah, 64. Because it's a 16 gauge. Okay. Uh, Next is sheet metal rule K factor. Check it out. Okay, K factor is uh, how you deal with the corner. And I'm going to go with the 0.01 inch K factor. Mhm. All right. So we're going to go, I set up 0.01 and the spline factor. Okay. Yes. So spline factor 0.1. Okay. And apply. Okay. So this is the 3D, okay, side wall, and we're gonna get to choose one of the closest edges, okay, and we're going to use flange option. The flange, all right, is going to have the length of this much, and it's important that we choose this number based on where the center is, and the center is going to be right at the center of the curve, all right. All right. The third option, second option from the beginning, and you want to apply this and close. Okay. And we're going to continue. Okay, the flange, again, the similar way. Again, pick the top corner, but this time height is going to be. You have to find these numbers yourselves. Okay, so I'm just, and apply. Cool. Material is important, of course. You always go to material. Material is supposed to be aluminum, uh, 16 gauge aluminum. Aluminum 661 is a very high quality material for this kind of business. Okay, that you can use. Okay, so uh, what else we do? We again add another flange. Okay, and apply. Of course, it's important that what happens at the corner here, and we do not want to leave the space like that. Um, so for that to happen, to close the gap, okay, you choose two corners and line up with each other. The gap size is going to be extremely small. Apply. I'm setting the gap size as 0.01. So basically, um, this distance can be reduced down to near zero, okay, by just simply using the seam, the corner seam option, okay, and we're using is dimension gap dimension of 0.001. Okay, this is the closest amount number I can get, okay, and it accepts it now. All right, face to edge distance and 001. Okay, that's pretty close, and that enables you to do anything you want. You can just simply weld it or solder it, or you can close that gap. Okay, and we can do the same thing over the other corner, opposite corner. Okay, and we're gonna go click on the corner seam option. Okay, and then make sure that you have the corner. Okay, options are set to standard corner options, and then band. Okay, default band. Okay, there's no band, not a perfect, and the shape is going to be selecting with the edge, and maximum distance is again 0.01, and then you pick the corners, okay, and then apply it, and you get to see the gap is closed as much as possible. It's extremely small, and if you want the waterproof, okay, gap, then you're going to have to weld it or solder it, okay, in that area. Number of other options are also available, but for the purpose of this right now, we're going to click OK and move on to other corners, okay? And we're going to do this also the other side, okay? And we need the flange option. We're going to choose the upper corner edge of it, okay? And apply. And make sure that the corner is covered by just corner seam. Corner seam supposed to be again similar to one with the gap option of 0.01. Okay. Corner seam. Okay. So the material is very important, and material is going to be yeah, as you have chosen the default. We are selecting the default material, and just make sure that you get the same material, same finish. Okay. And it's welded option, the welded material. We're going to be weld these corners. Okay, so, well, that's about it. Okay, so I just want to demonstrate one more thing to you. Right now, there is a button over here, or the command on the top for the open view. You move your cursor over the top in the middle and click on it. Okay, and just to see how everything works together. So I just wanted to demonstrate how to handle the corners, and there are multiple ways of doing the corners, and then I'm just trying to pick the most nonsensical way. Okay, just simply select the corner you're looking for. Okay, and this edge did not satisfy me. Okay, and this corner is, I'm just gonna simply erase these two corners, delete and delete. Okay, and go to corner seam option. All right, and then choose the inside edge and outside edge of the opposite corner. Okay, and then select the option of 0.01 gap. So that gap is as close as you can get to 0 inches. Okay, and apply it. Okay, and that's a better corner than I earlier just picked up. Okay, that, and it will work better, and because it's easier to soldering on the outside or inside. Either way is fine. It's a personal choice, it's an engineering decision, and depending on the situation and the manufacturing process. So you can do the same thing at this end too, and you can go simply go to seam gap, corner seam, and then select the gap of 0.01, and then select the insides edge and the outside edge, and you see, if you see everything is working fine, extended already in green, then click apply. Okay, and then we're going to keep doing this. All right, okay, so again, we have similar situations here. So what I'm going to do is I'm going to erase the one that earlier I set it up and delete, and move my cursor over corner seam, click on it. Okay, and setting is already became default. Previously gap is 0.01, and we're using the medium gap. Okay, so all you're doing is selecting the outside edge and inside edge, click and apply, and we're done. Okay, I think we need to do this a few times, a few more times. And I think the corners are coming far better. And I'm just checking if there's an earlier version of this, which I need to erase, and I'm going to erase it first. Okay, and then we go to gap seam, corner seam. All right, and select the exterior and inside and apply. Okay, I think this is a far better solution. Okay, and the question is, what do we do about these corners? Okay, they're going to be welded or soldered depending on the material, and welding is very common in aluminum, and the soldering is more common in the tin or steel or iron plates. So This is it. This is the product, and we're going to 3D print it, obviously, everything. And this also can be viewed in a particular way. Okay. And I just want to simply demonstrate how it is possible to see what it looks like unfold. So move your cursor over the top right hand corner, okay, under the sheet metal, and create a flat pattern button. That's the second one from top right and second one from down. Okay, click on it. It will show you the cutout. Okay, this is the developed view. It is called developed view in the world of engineering. Okay, and take a look at it, because this is the way it's going to look appear on the manufacturing drawings. And when you click on it again, it will come to that. Okay. Well, thank you very much. And I'm just give me a call. All right, call me, raise your hand if you have any problems, and we'll come together and fix it up.